But yeah, even though not everyone's arrived yet, I'm just going to get started. I am recording. So I'll start by sort of revising what it is we were supposed to finish last week in the last lesson that we had. And then we're going to speed through what would have been like the last full lecture, because it has previously taken me sort of 1.5, so like 1.5 lectures to get through the final lecture on database connections, but we can get through it quick, I think. Can definitely be faster than what I was doing. Okay, anyway, so let's just jump into it. Last week in our last lecture, we had a sort of database like this. It had two tables. It had a genre table and a book table. We inserted a bunch of data into the genre table, and we inserted a bunch of data. We're not going to make it to revision today, Creflo, but if you mean in like our next lectures, any lectures we have after this, yeah, we'll be doing revision. We're gonna leave you guys most of November to focus on sort of, yeah, to focus on your exams or tests or whatever you guys are doing in November. But then after that, we'll, yeah, jump into revision before you guys write the exam for this course. But anyway, so we had this database, we had a bunch of information and data inside genre, we had a bunch of information inside book, and we learned a bunch of different ways to query and work with that data, right? So like the last thing we stopped on is we have these two tables, the foreign key, the table that they're linked on is like when genre ID, so when the genre ID equals the ID in the genre field, then that genre's name should display. Okay, so like how we joined the two tables is we said inner join genre on, and then you have to give it what columns it's joining on. So in our case, it was book.genre ID equals, so book.genre ID must equal genre.id. Okay. Now, guys, I am on that site, DB Fiddle, so you guys can run this all locally yourself as well if you're interested in doing that. Let me just, okay, I just posted all the code into the chats. If you're following along, you're welcome to sort of type it out. But it is a simple, there's just one more simple thing I have to show you. You can see that this is getting very long, right? And we can treat this all as like one big table, this book inner join genre on, we can treat that all as one big table. So out of interest, do you guys remember how would I filter out certain rows from my query? Because you can see currently it's giving all of the rows inside this big table, this joined table. How would we add like some extra little restrictions? Do either of you guys remember? How would we add some extra little restrictions? What if I only wanted books from a certain genre to be displayed? I don't want every single book in the whole table to be displayed. Which SQL command would I use? Which word would I use to filter out certain rows from the query? You don't remember? So select is the statement we're currently using, Tariq. But what if I only want to select rows in which a certain thing is true? How can I be more selective, if you like, about which rows that I choose? Okay. So the word we use is where. Okay, where. So for example, if I wanted to select all the books where the genre is fiction, I would say where genre, so that's the name of the table, dot name equals fiction, right? Where genre dot name equals fiction. And now it's going to filter out these 5 responses and it'll only give me 2. Okay, so fiction, fiction. See, both of them have the same genre. So now it's only showing fiction books. So the word we use is where. But you guys can see that this query is getting very long, right? Like let's say on this day, so Today, someone in the company comes and asks me, hey, can you give me a list of all of the fiction books that we have? Then I'd give them something like this, right? But then if the following day they come and they say, okay, now I want all of the philosophy books that we have, then on that next day, tomorrow, I would have to go, okay, well, I'll get all the philosophy books then. That'll be select star from book, inner join genre on book dot genre id equals genre dot id where genre dot name equals philosophy. Okay. And then let's say the following day they come and they ask, okay, can you get us another list with all of the education books? Then I would have to type this whole query out again. And the only thing I would replace is where genre.name equals education instead of fiction or philosophy. That's the only thing I would change. Okay. You can see that this is a lot of typing, right? This is a lot of typing. Like these queries are getting quite long, and you can imagine a query getting even more complicated than this, right? Like where genre name must be philosophy and the author must be like this author, or if you're linking to another table, you know, it could get like extremely complicated. These queries could become very long, and you could be using them very frequently. So when we're using a query so frequently, we might want to sort of just save it, if you like save it in the database. But could I ask you guys this? If we were in C# and we had a piece of code that we were using very often, you know, and we didn't want to keep typing it out every single time we want to use it, and we're using it very often, maybe in like slightly different cases, but very frequently. What would we use to store that code? Do you guys know? What would we use? What is the sort of coding structure we would use to sort of save that code and we can use it anytime we want? So that's how we would save a lot of data, Tariq, but not code, right? We don't save code in that. That's how we save data. Where would, if we were using some code frequently, what would we put it in? What would we define in our code to hold that little piece of code that we're using so frequently? Okay, they're in classes. You're very close, Creflo. They're in classes. What do we put in classes that just hold some code that we're using frequently? So think about it. It's almost like defining a certain action that we can perform or behavior. They can be abstract. They can be abstract. Not always, though. How do we define behavior in a class, guys? How do we define certain behaviors, certain algorithms almost? If we had a specific algorithm, a particular thing that we were doing very frequently, what would we put it in? What structure would we put it in? Okay, methods, guys, methods. So yeah, we would put it in a method. And so SQL has the exact same thing, okay? SQL has the exact same thing. They're just not called methods. So this is some code that I would be, don't worry about it, don't worry about it. It is like a fairly vague, it's a weird question to be asking in this context, but it's good revision to like connect these things in your head. So you can see I've got some code here. I'm using it very frequently. The only thing I'm changing is this one little bit, right? Like there's a whole bunch of ways. The whole bit of code is exactly the same. It's just this one almost like variable, this one condition, this one parameter that is changing, right? Like I'm changing it between fiction, philosophy, and education, and whatever other genres I have in my database. But you can see the whole query is the same. It's a very similar piece of code that I could be running very frequently. So in C#, I would put that in a method. In JavaScript, we would put it in a function. And in SQL, we would put it in a procedure. Okay, so now we've learned 3 different languages. All of them have a different word for describing method, basically. It always just means method. Okay, it varies slightly based on the version of SQL you're using. About 100 years ago, when the MTA textbook was created, this is how they created a procedure on the left here. So just get familiar with that sort of structure. It's not too bad. But a more modern way of defining it is this thing on the right, okay? So like all the other SQL commands we've learned, they're fairly straightforward. They're English, basically. We say create procedure, the name of the procedure. It looks a lot like a C# method. You can see it even has the brackets there. Instead of curly brackets, we say begin and end, okay? So instead of the opening curly bracket and closing curly bracket, we say begin and end, okay? And then there's some little other subtleties that I'll explain to you now. Yeah, it is a little bit old, but it's okay. It's not a terrible resource. So cool. So we're going to create a procedure to save just this first query for now, and we'll discuss how to get the other ones in there as well just now. So we would say create procedure, create procedure. We give it a name. I'm going to call this one get books. Okay, get books. So that's the start. Then we would say begin, okay, end, and then we just put whatever query we want the procedure to run there. Okay, so I put the query there. You close this line, and we close the end as well. Okay. Now, can you guys tell me just thinking about how a computer thinks, how the computer will operate when it reads this, right? Because it's going to read this character by character, right? Character by character. It'll read all of these characters, okay? How can you predict a computer would get confused about what we just wrote here? Can either of you think about like why this statement here might confuse a computer? Things might break a little bit. Can you guess why? Look at all the other queries. Look, I'll give you a hint. I'll say, look at how all of the other queries end. How does SQL know when a statement is finished, when a query is finished? How does it know? Tell me that much. So yeah, start by brainstorming that, I guess. How do we know when the statement is finished? Oh, I see we've got another. Shale, welcome. Yeah, exactly. The semicolon at the end of the line. So knowing that now, Creflo, what is confusing about this statement here? What is confusing for a computer, the way a computer thinks about what we just wrote here? There's two semicolons in one statement, precisely. More specifically even is it doesn't know when the create procedure query ends, right? Because when we say create procedure get books, we say begin, we write out this whole query, this semicolon over here. How is the computer supposed to know that this semicolon is for the select and not for the create? The answer is it can't know, okay? It can't know. So we have to fix that, okay? So we have to address that problem. It doesn't know that the end and this semicolon are for the end of the create procedure, and that this semicolon is just for the select procedure. So there's a specific way that you handle this problem. Okay, and it's fairly straightforward. It looks confusing, but now that you've sort of maybe thought about it yourself a little bit, it won't look too bad. So what these semicolons are called, all these things that specify an end of the line in any program, they're called delimiters, okay? Delimiters. So what does that mean? So D, that stands for separate, like that's prefix in English means like separate, like it does in words like defense, right? Defense, that's like separate with a fence, right? That makes sense. That's what defending something is. And yeah, so delimiter, it just means to limit like the end of the line, to specify the limits of the line and to separate the lines, okay? So that's what it does, it delimits things. So we can change the delimiter. You see SQL knows what this word means. It's highlighted in blue. So we can say delimiter // And what that means is for the rest of this file, for the rest of this schema here, for all of the code below this line, instead of treating semicolons as the end of the line, it treats slash slash as the end of the line. And now that semicolon after end, we're going to replace with slash slash. And now it will no longer be confused. Okay, so that's all we're doing there. And now, instead of writing out this whole query every single time, we can just say, call this procedure. This procedure is now saved inside our database. So we can say, call get books. Call get books. Okay, and you'll see that it runs that query. Okay, it goes and runs the query that was saved inside our procedure. Okay. But now you saw, so if I wanted, so this is getting fiction. If I wanted to get philosophy, maybe I would have to add another procedure called get philosophy books, or another procedure called get education books if I wanted to get education books, which seems a little bit crazy for define a procedure for every single genre. That's silly, right? So how we actually do that is there's another thing, like just like in C#, where if we had a method that took in two integers like int a and int b and returned a plus b, just like in C#, inside SQL with our procedures, we can also define parameters that get passed into the procedure, just like we can define parameters that get passed into the method in C# and parameters that get passed into functions inside JavaScript. So here we have another called parameterized procedures. So this just means that your procedure is now also taking something in. And to designate that it's taking something in, you say in, you give it the name, you give it the SQL type, and that's it. Then you can use that parameter inside your code. So I'll just show you that now. Instead of specifying a hard-coded genre there, like instead of literally typing fiction or philosophy and specifying it in the procedure, we can just say, okay, this takes in a parameter called, so in, called genre. So that's the name of the parameter. And its type, what type is it, guys? What type is genre? What type is genre? When you look at this, what type is this? It's a string. Yeah, but we're in SQL. Is it a string? What are strings called in SQL? So it is a string, basically, 100%. Yeah, exactly. So it's varchar, and then you give it a length, a maximum length. So we're going to say varchar 255 is the type of the parameter. Okay. But yeah, it is basically a string. But yeah, be careful, because all the languages are just slightly different. But you can see it's the same logic. So learning one language will always help you with others. Okay. So now this takes in a parameter called genre. And so now I say genre.name equals genre. And so now when we call get books, we can just specify whatever genre we want over here. So like philosophy, for example. And now it will call that query, and it's just going to replace genre with philosophy, and then it gets all the philosophy books. We can replace genre with fiction, and then it gets all the fiction books. And we can replace it with education. Oh, did I spell fiction wrong? I did spell fiction wrong. Okay, there we go. Now I spelled fiction correct, so it gets all the fiction books, and I can get education as well. So then it'll get all the education books. Okay, cool. So that's that. That is procedures. And that's in fact all we had to learn about SQL. That's the end of what would have been last week's lecture. And so now, yeah, we can jump into what would have been last week's lecture had we not missed it. And we're going to speed through this a bit, but it is, I mean, it's interesting. It's easy, I think, or quite a lot of the stuff is pretty easy, and you've seen quite a bit of it before. So yeah, let's just jump into it. I do have a Mentimeter quiz, but because I'm already going to be using some of your guys' extra time today, I think I'm just going to like jump into the lecture, and we'll do the Mentimeter quiz when we start revision. You know, we'll start doing all the tests and quizzes and questions, okay, that to prepare you guys for the test. So we'll save that extra stuff for then. Cool. So the first part of this lecture, so this lecture is basically just about how exactly do we work with databases inside C#. Yeah. That's good to hear. So this part of the lecture, we're actually jumping back to C#, is how do we work with databases inside C#? So we've seen how we've worked with databases. We've created a simple database. Yeah, we've seen a bunch of stuff, but like if I'm inside a C# application, how do I work with the structured data inside C#? And it's actually super easy. Like it's super easy. So yeah, let's just jump into it. The first thing I want to cover is this idea of XML. You guys have heard about XML before. Do any of you remember where from? In what part of the course content did we first hear about XML? Very specifically, it was a specific section that used XML. Do you guys remember? The HTML stuff? Yeah, so it was in the web development section, but it was, I mean, in the web development chapter, but what section of chapter 4 was XML? It was used in conjunction with a very specific thing. Not all websites use XML for everything. You're right, HTML is also a markup language, so they are related in that way. Markup languages are languages that are designed to be read by both humans and computers. That's what a markup language is designed for. But XML in particular, where we heard about it was in our discussion of web services. Okay, web services. If you guys remember the web service description language and SOAP, the simple object access protocol, where it had like an envelope, a header, and a body, that was all XML. Okay, so all of that stuff was defined in XML. And all XML is it's a text-based way to represent structured data. Okay, a text-based way to represent structured data. Now that definition is fairly abstract, but I think when you actually see XML, so here I have an example of some XML, and this XML is perfectly fine. You could actually use this, and we'll actually use some XML very similar to it right now. But when you look at this XML, guys, so I haven't taught you XML, and the thing is that I don't need to, okay? Because just read through this line by line, and you guys tell me, what is this XML about? What is this XML about? What is that XML trying to say over there? Could also ask you, where would this, okay. Is that all though, Kreflo? Read a bit more, read more lines. Is it just the stock price of? I mean, it is close enough, right? But you can see that there's more than one company here, right? There's more than one. Yes, okay, cool. So there's more than one company, okay? So there's Tesla and a company called NIO. Okay, and so we've got company ID equals NIO, company ID equals Tesla. So these are the two blocks defining our two companies, and we have the company name of each of them and the stock price of each of them. Okay, so yeah, this was specifying a list of companies and their stock prices. I'll give you a slightly, probably a little bit more difficult, but it's impossible to make XML difficult, really, to be honest. But here on the right, like, what is this XML referring to? What do you think that is? What would the XML on the right be? Where would you see that? Anyone have any ideas? The profiles of different social media users. There is definitely a username there, but is it really intentioned? Is it representing their entire profile, Shale? Or is it more specific than that? Yeah. Okay. So there's a username and a description. Yeah. Okay. So the username is the user who uploaded the image. The description is the description of the image, and URL is the URL at which you can find the image. Okay. But yeah, you're correct. You guys saw that it is related to users in some way, but you can see it's images, image ID equals 1, image ID equals 2. We've got 2 users who each uploaded an image. They gave their image a description, and obviously we stored their image somewhere. Okay. But it's fairly straightforward, right? Like you can see that XML, it's pretty human readable. Like it's pretty straightforward to figure out exactly what's going on. Cool. So what is XML? Let's go a little bit more in detail, but you can see that it's fairly self-explanatory. But let me just explain the name. Yeah, those are real links. Yeah. So XML stands for Extensible Markup Language, extensible. Why is it called extensible? That basically means it can be extended, right? It's called that because you can make up your own tags. If you guys remember in HTML, we had like an image tag, a paragraph tag, a title tag, a style tag. We had all of these tags, but we couldn't just make up our own tags, right? HTML defined the tags, right? HTML defines certain tags, and those tags have certain meanings. XML doesn't really do that. In XML, you can just make up your own tags entirely. The name of the tag is totally irrelevant. XML doesn't care. As long as tags that are opened are also closed. Okay. So XML, you can make up the names of your own tags. That's why it's called extensible. So that's one thing to know about it. The next thing to know about it is what this first line is defining. The only weird part of XML really is this first line. That's just specifying the version of XML that you are using. And we spoke about encoding a while back, but it doesn't really matter. You don't have to understand this first line really. You must just know that it's called the XML declaration or the processing instructions. Okay. So if you were asked, like, where do you specify the version of the XML of the version of XML that your document is using, you could say it's specified in the processing instructions. That's what this first line is for. Okay. The next thing to know is just some terminology. So we refer to XML elements. XML elements. An XML element is any pair of an opening and closing tag, any couple of an opening and closing tag. It doesn't matter how large it is, okay? So companies to companies, that is one XML element. Company to company, that is an XML element. Company name to company name, that is an XML element. Description to description, that's an XML element. Okay, so any pair of opening and closing tag can be considered an XML element. Okay. It does get a little strange. So like I know that in C# specifically, they actually refer to either the opening or the closing tag as the element. But you'll see now what kind of language they use. Okay. Okay, but yeah, it's probably easier to just show you this in code actually, because it's fairly straightforward. So in C#, there's a namespace called system.xml, system.xml, that's a namespace. And inside system.xml, there's a bunch of classes and methods that we can use for reading XML documents. So there's an XML reader, which reads XML, and there's an XML writer, which writes XML. Okay, so we're gonna jump over to that, and then we'll see what goes on, okay. Cool, so I'm gonna create a new project quick. It's just gonna be a console-based application. Okay, sorry, Visual Studio, as usual, is a bit slow. Okay, there we go, console app. Next. Console app 1, cool. I'm gonna call this Roosevelt 06. Okay, we'll save it in workspace. Okay, cool. And yeah, that's that, I think. Okay, so while that loads, I'm going to jump over to this folder and just show you this. So you say open with Notepad. Well, a lot of Microsoft applications are very clunky because they're, yeah, it's just because of how they're developed, I guess, the languages that they use. But they do have a lot of functionality, so that's an advantage. Okay, guys, so more XML here for you to read, just to practice. So just so that you get comfortable with it, what is this XML showing, guys? What is this XML showing? I think this one's fairly straightforward. What is that XML trying to show? Emails, right? Yeah. Okay, we've got two separate emails here, right? So there's this email, which has a certain person that it's to, a person that it's from, a subject and a body. And we've got this email, which is to, from, subject, body, okay? Obviously, there's no email address here, but you can imagine. Okay, I guess this is kind of more like a chat function or something like that. But yeah, anyway, it's something like that. So, regardless, it's fairly straightforward to read. That's the point. Okay, so how do we read this into an HTML document? And actually, it's fairly straightforward. I think you guys will see now. Let me just tell you guys where we are. This stuff is on like page 167, but I'll type it all out here anyway, so it'll be okay. Cool. So what I'm going to do, I'm going to move emails.xml to a place where our program can easily access it. So we're in Roosevelt 06, console app 1, bin debug. This is probably where the code will compile to. Like where the executable, the .exe that I'll run, this is where it'll be. So I'm going to throw emails right there. And yeah, we're going to read that emails.xml document just so that you guys can see what goes on. Okay, I see Bryn isn't going to make it. Looks like, Teddy didn't make it either. Pity. So cool, let's jump into it. So I'm going to say using system.xml, using system.xml. Okay, like so. Using system.xml, because that's the namespace that holds the XML reader. And then we just have to open an XML reader that is going to read from the XML file. Okay, so it's not too difficult to do. It's very similar to how we create other objects. I'm going to say XML reader equals. So I'll show you now what this says. So I'm going to say XML reader.create. How can I show this to you guys nicely? Represents fast and uncached. So you guys will notice that I'm not saying new XML reader, okay? I'm not saying new XML reader. I cannot create an instance of this class. I'm not able to create an object of it directly. Do you guys remember what that means from chapter 2? What type does this have to be? What type is this? Because I can't create an object of type XML reader. So what does that mean? What type is XML reader? Or not what type, but what keyword was used to declare XML reader? Does anyone remember? You guys actually mentioned the keyword earlier in a different context. It's a keyword that means you're not able to create an object of it directly. That's what the keyword means. Okay, it looks like no one remembers. So I'm going to, okay, you do remember. And you can see I can mouse over it. And you see, Creflo, just to prove that you're right, it says cannot create an instance of the abstract class or interface XML reader. So you're correct, it is abstract, or it's an interface, but you guys know that interface just means public and abstract, basically, right? Okay, anyway, so we've got an XML reader here, and we're going to say, all right, XML reader.create. Okay, so I'm going to create an XML reader. Notice I can call the create method without creating a thing, an object of type XML reader. Does anyone remember what that means? In order to be able to call a method without creating an object of the class that it is in, what type is that method? Do you guys remember what that means? So if there's a method and you need to call it without creating an object of the class that it is in, without instantiating the object, what type does that mean? Hey, yes. Okay, so the create method is static. Oh, Tariq, I see you said abstract as well. So, okay, no, I'm impressed, guys. It's cool that you remember that stuff. So that's legit. Okay, cool. So we've got our XML reader there. All right, so that's going to go ahead and create an XML reader, and it's reading the emails.xml documents. Okay, so we just specified the emails.xml documents. Cool. So that's that. Now we can read it, actually. We can just go ahead and read it. So I'm going to say while reader.read. Okay, by the way, I'm going to mouse over this one more time. And you can see, so there's a couple of things that it mentions. I need to go. Oh, we will. Don't worry. Chapter 2's tough, but there's a lot to remember. So it says represents a reader that provides fast, non-cached. Okay, those two words. Obviously, it's fast, so that just means it's quick. Non-cached means it's not stored like inside cache memory, which we discussed a little bit in chapter 4. Jennifer of Wengerberg has joined. Really? Huh. Oh, okay. The very funny. Okay, so I thought someone was going for a creative nickname. Hello, Jennifer. Welcome. So you can see it says fast, non-cached, forward only. Okay, forward only. That matters. Forward only. Okay, guys, all that means is you read each thing once and only once. It's forward only. There's no going backwards, okay? It's like you read the XML elements. You read emails. You read email, to, from, subject, body, email, okay? You read forward only. It only goes in one direction. You can't go back, okay? There's no going back. You process each item once, okay? So that's what this XML reader does, and you'll see that now. So I'll say while reader.read. So all this is saying is while there is something to read, so as long as there's another element to read, and all we're going to do is print out, let's just print out reader.name. Okay, we're just gonna, for now, we're just gonna settle with that. We're gonna say console.writeLine, reader.name. Okay, like so, reader.name. So let's see what this program does. I think you guys can agree this is a super simple program. It runs while there is more stuff in this XML reader to read, and it just prints out whatever reader.name is. We don't know what reader.name is. We can read the little blurb. It says, get the qualified name of the current node, Okay, so let's see what it means by node. Let's see what it means by node. So what I'm going to do, I'm just going to say build solution. Okay, build solution. I'm going to open up command prompt quick. There it is. Okay, so I've opened up command prompt. I'm going to change directory. You guys know the chdir command. If you guys did the little tutorial where you made your website, you guys know the chdir command. I'm going to change directory to where the file was compiled to. Okay, I said chdir. It must be chdir, change directory. There we go, accidental typo. You can see over here, we've got console app 1, there's emails.xml. So console app 1 will be able to find emails.xml. They're in the same sort of directory, okay? So there we go. I'm gonna run this now. So I'm just gonna run console app 1, okay? Console app 1, there we go. And this is what it prints out. It prints out XML, emails, email, to, from, subject, body, email, to, from, subject, body, email, emails. Okay. So what's going on here, guys? Do you think this looks sensible? Is that what you expected from printing out reader.name? So remember, this is printing out the name of each node, the name of each node. So we know what an element is, right? So an element would be like email to email. That's one element. 2 to 2 would be one element, right? But a node is just that, or just that, or just that, okay? So just that, I mean. you can see there's also a new line between each one. Why is there a new line between each one? So these are the questions that I want you to explain to me. Okay. First, I want to ask, what do you think there's something weird here? Is there a question you have about what it printed out? Do we find something weird about what we've printed out here? Quick. Anyone? Can someone explain to me why each thing is printed out twice? Right, because we have XML, emails, email, to, from, subject, body. So it only printed emails once, and then it printed email once, but then it printed to twice. Why is that, guys? What's going on? The opening and closing tag, exactly. Okay, so you guys get that. So yeah, it's the opening and closing tag. You can see the second email comes later, right? Because that's how it is in the file, right? We've got emails, then email. So it prints each of those once. Then it prints out to, it prints out to again. From, it prints out from again. Subject, it prints out subject again. Body, it prints out body again. And then it gets back to email, right? That was closing that email. Then it prints email again. It prints to twice, from twice, subject twice, body twice, and then it closes email. And then finally it closes emails. Okay, so that's that. That makes sense. Easy peasy. Cool. And why is there a new line between all these tags, guys? What's going on with that? Why is there a new line all over the place? Anyone have any ideas? Because we're printing the nodes. Okay, yeah, no, I like where you're going with that. And it is kind of like that. So the issue is that everything in between them also counts as a node. Okay, so emails, then there's this node defining this whole big thing in the middle. Okay, if that makes sense. Okay, so there's a value. It's easier to picture with these tags, right? So there's a to, then there's this middle node. Okay, in this case, the middle node, it doesn't have a name. It does have a value. Okay, it does have a value. Its value is Ali. And this one's value is Josh, and this one's value is plans, right? So they've got this middle node here, but it doesn't have a name. Okay, and that's why there's this blank line, because there's two, that's the name of the first node. Then there's that middle node that doesn't have a name. And then there's another two, because that's the name of the closing tag as well. Okay, so that's what that is. So that explains that. That's the mystery behind all of that. Cool. So now we can check some stuff. So there's a fancy little command, because when we're processing this, right? So when we're processing this information, what we want to do is we only want to process the text once, if that makes sense, right? Like I can't just say, okay, instead of that, I'm going to print out reader.value. Okay, this won't work to just print out reader.value. Okay, so that's the value that the node is holding, if that makes sense. You can see that that doesn't really give me the nicest format. It's pretty confusing. Although you see we do get all the right values, but you get all of these ridiculous new lines over here, right? And then a whole bunch of new lines over here and a whole bunch of new lines over here. Because now the next problem we're running into is that, so these have value, right? Ali, Josh, plans, want to get some breakfast, or Devin, job offer, you got the job, okay? So these are the values that it prints out. Those are the 8 values that we have, right? Every other node also has a thing called value, right? It has a dot value, but it's blank, okay? So the XML, it has a dot value. You can say whatever this first node is, dot value, okay? It just happens to be the case that it prints out nothing, okay? Likewise, emails.value prints out nothing. Email.value prints out nothing, okay? So it goes through that list of all of those different nodes that exist. It tries to print out their value. It just happens to be the case that the values are blank, okay? So we need to process this in a more meaningful way. And in particular, we also only want to process each value once, right? So what we're going to do, what it allows us to do, this XML reader, is it allows us to ask, and sorry, we'll do a break at 15:55, because remember, I did say I'll probably cut into some extra time today. Ah, Dape, you made it, welcome. Okay, we've got a fairly good crowd here. That's cool. So we can check if it is a start element. Okay, so if we say if, okay, if, and we can say reader dot is start element. Okay, is start element. Okay, like that. All right, cool. That's gonna, so this will immediately be better. Okay, and if it is a start element, I'm gonna say reader.read, okay, to read the next thing. So it's gonna be like, if it is a start element, it'll go to this next bit. It'll be like, okay, reader.read. So this too, this is a start element. It would go, okay, I'm started, next, and it'll reader.read, and it'll print out, then it'll just print out Ali. Okay, so it'll read the next thing. Okay, reader.read, and then we're gonna say, okay, print out whatever the value is now. Console.writeLine reader.value. Okay, cool. So that might be a little bit better, but this actually has a problem as well. Okay, this has a problem as well, because you can picture emails. This emails is a start value. And then it would go, okay, emails, this is a start element, right? It's the first tag, it's the opening tag. It's gonna go, okay, cool, I'm a start element, reader.read, console.writeLine value, and it's gonna print out this here, okay, nothing. So how do we deal with this? There's all of these different tags. There's so many different options, and I need to check if one of these options applies. So how would I do that, guys? How do I check something like this? How do we check a condition like that? How do I check if the name of the node is like email or body or subject? How would I check that in C#? Anyone have any ideas for how we can do that? How would I check the... How do we check a condition, guys? An if statement, that's a good suggestion, yeah. Good suggestion. There's a lot of options here though, right? So that is definitely one way we could do things. We could be like, okay, if the name, okay, so it's a start element, cool. So it's a start element. That's good, a good start. So we check that condition here. It's a start element. So is it an opening thing? We could then go like, okay, cool. So if reader.name is equal to body, if reader.name is equal to body, then we're going to do something. But there's a lot of options here, right? We could be like, okay, if it's subject, we're going to do something else, right? And then we could go, okay, cool. If it's the to tag, then we're going to do something else. If it's the from tag, then we're going to do something else. Is there a better way to do this though? What other decision structures do we know of that are more appropriate for a task like this, when there are so many different options? There are so many different possibilities for what reader.name would be. You might call it multi-branching, right? Because that's the other thing. You don't want to check every single one of these ifs. You would be something like else if, right? And then this one would also be else if. And then this final one might be else if, and then and then the final option could be like a else. But can you agree that this is a lot of code for such a simple decision problem, right? So what is another decision structure that we know of from way back in chapter 1? Hey, Tariq, cool, yeah, exactly. So it's switch over reader.name, okay? And now I can specify all of these different cases much more succinctly, okay? So switch over reader.name, and now we can just get each case. So we can say like a case, let's say for now, we're just going to do the subject. You can imagine if we did the rest. So we can say case subject, okay? We'll do something if it's the subject. We can do, okay, case body, and we'll do something if it's the body. And in all other cases, we'll just ignore it. Okay, we'll just ignore it. So if I say case subject, that would be something like, okay, cool, console.writeLine. So we're going to reader.read. Sorry, we're going to reader.read one more time. Then we're going to say console.writeLine. And here, let's say I'll print out, what's that nice way of doing it? Yeah, we can do it that way. We can say something like subject is that, I think. Yeah, cool. Ooh, that should be a 0. Okay, there we go. And then I could also say like console.writeLine. Okay, and if it's the body, we're going to print out that this is the body. Okay, I'll put with a code on body, and also the 0th argument will be the value. Okay. But we also have to reader.read here again. Reader.read. Okay. There we go. So that's using our switch statement. So if the current node is subject, we're going to read one more time so that we get out the value held in it, right? So let me just explain the logic there again for in case someone didn't get it. So if the current node is subject, that's like the case there, case subject. So if reader.name is subject, we're going to read one more time. So that's going to give us this node here. And we're going to get the value of that node, which in this case would be plans. In the next case would be job offer. Okay. And then we do the same thing if it's body. Okay. So I'm going to build that. And you'll see that this now will give us a fairly nice reading of that. You see, so it says subject, plans, body, want to get some breakfast tomorrow, subject, job offer, body, you got the job, when are you coming back to South Africa? Okay, cool. So that's how you read an XML document. I think let's do like a 7-odd minute break. Do you guys mind that? So we can like break till 4 now. And yeah, you can get some water, chill out a bit. If you have any questions, ask them in the chat. And then we'll come back, and I think we should be able to get through the rest of the stuff. Okay, there is quite a lot. Although, no, actually, it's not so bad. So it's three topics, basically, kind of. 3 little topics. We should be able to do it. And they do feed into each other quite nicely, actually. They do feed into each other quite nicely. I think it would be better to do them all in one lecture. But we definitely won't be done in 30 minutes. I can tell you that much. So it will take a little bit of extra time. Or a lot of extra time. So sorry about that. But then that's it, guys. You would have finished the course, so congrats. Sorry, I just stopped sharing my screen so that I can fill out the register quick. With who did arrive. See Jennifer disconnected again. So I guess that's a kind of yes. And Dape, you're here. Ooh, I should say like, yeah, instead. And Shale. And okay, I think I got to everyone. Yeah, I guess so. You'll probably at university, you'll be skipping a lot of lectures anyway. Where would you study? Wits. Okay. Cool. That covers that. Okay, cool. Yeah, both good choices. Yeah. Not really. Maths courses are difficult. And like most universities will have sort of thinning courses, like courses that are designed for most people to fail. Particularly in like sciences and engineering. So yeah. Like at Wits, there's calculus and analysis. So in second year analysis. And in first year calculus, where the pass mark or like the pass rate is something like 30%. So yeah, like 70% of students fail, which is a bit messed up. After this, we are done with everything. Yeah, with all the course contents. I mean, you still have to do revision for the exam. But yeah, all the new stuff, everything will just be revision after that. But I mean, if you study the math stuff a lot, then you'll be fine. And a lot of you, like I know Wits, there is kind of a way out. If you're studying computer science, you cannot do maths. I'm not sure how good it is necessarily to be skipping maths, but probably increase most people's marks. So for comp sci, are they taking your grade 11 math marks? They'll consider everything. I mean, you apply based on your preliminary results. So you can get preliminary acceptance. But they'll consider your next year stuff as well, your next year marks, your matric marks, I mean. And when is this exam? I'm as much in the dark on that as you are, Dappe. The tutors, I think we're discussing it on Thursday, like because everyone's filled in the form now. You know, that form that we sent around where you say when you prefer, like either next year or first week of December. And I take it Brighter Futures Management will tell us. Oh, okay. I'll post it after this lecture again on like the group or whatever. I posted it on WhatsApp. I don't know if I posted it on Discord though. But yeah, basically they'll tell us now like when exactly we're writing the test. Oh, right, no phone. Yeah, no, it was very long ago though, Dappe, very long ago. I don't know when your phone was stolen, but it was like 2 weeks ago when I posted that form. Is it possible to skip straight to second year comp sci since I'm done with? No, it doesn't work like that. Because then you could just do AP maths and like, yeah, because passing school AP maths, even though you learn a lot of the same content, you know, doing a course over the whole year in the university setting, it's different. Because a lot of people like just party at university. So it's as much about your sort of focus and stuff as it is about whether you know the content. Okay, cool. So yeah, let's jump back into this stuff. Nice discussion though, guys. Yeah, exactly. Social life, studying, or sleep. With really good time management, you can pick two. Okay, anyway. So let's do it. I'm just going to remove all that code because we don't need it anymore. And yeah, exactly. That's with good time management. Usually it comes down to more like choosing 1.5, at least in a lot of years. So cool. All right, so over here I have a database. Okay, so I've got a database open. It's running on my computer. It's called the AdventureWorks database. It's a very, very big database. It's got a lot of users in it. So I'll show you some of the tables that exist inside this database. So you can see I've got tables here. I'm going to open up tables. You can see these are all the tables in my database. Okay. So there's a person table, a password table, an email address table, a shift table, or shift table, sales tables, shopping tables, all of this stuff. Okay, there's lots of tables here. I think you guys can agree. Okay, inside the person table, these are the columns that we have. We have a title, a first name, a middle name, a last name, a suffix, an email promotion. So that's where we would send promotional emails to. We've got there's some demographics, the date when this field was last modified. So you can see there's a lot of stuff here. Okay, guys, this is a very complex, fairly professional database. Okay. And basically what we're going to do is just read from this database. So it's fairly easy to do that. It's exactly like standard SQL. So what I'm going to do, just to demonstrate to you guys, I'm going to write up a quick query to this database. Okay, I'm just going to write up a query for this database. When Visual Studio actually runs. Okay, so I'm going to write up a new query. Okay. And you guys will see that it's exactly how things were working on DB Fiddle. Okay, on DB Fiddle. One very, very subtle difference. Okay, so I'm going to say, cool. We've got this here. So, okay, over here. So here I can write a standard SQL query that's going to go and fetch stuff from this database that we have running. Let me just open the chat because I can't see it. There we go. It's annoying. Why isn't it just overlaying? I'm not sure. Oh, well. So I can say select star from, okay. Now, usually we would just say the table that we're selecting, right? So let's say I want to select things from the person table, okay, from the person table. But here you'll notice there is a subtle difference with this database. So you can see that there's these little brackets afterwards. So here we have a table called culture, okay? And you can see that it's got in brackets production. And here we've got one called bill of materials, and then in brackets production. And you can see all of these ones that have in brackets after them person, right? So address is the name of the table, person. Address type, person. Business entity, person. You can see here person, person, okay? So the name of the table is person, but there is also an object called person. And the person object contains all of these tables, okay? It's just a slightly different database schema, okay? It's just a fancy database schema. It's not totally necessary. It just means that you can use the same table name, okay? You can use the same table name in two different objects, if that makes sense, right? Like when you would want to do that, I'm not sure. But yeah, so you have to say person.person because it's the person object, the person table, okay? And we also have to specify the database. Sorry about that. So we say adventureworks.person.person, okay? .person, okay? Adventureworks.person.person, then we can run it. And you can see that it gives us this result. So this is the person table in the AdventureWorks database, okay? And you can see there are 19,972 records in this database, okay? So 19,972 people in the person table, okay? So you can see this is a lot of data. That's a lot of data that we'd be working with, okay? But the SQL query is super simple, right? Select star from adventureworks.person.person. Basically, select star from person. Exactly how we did inside DB Fiddle, where we said select star from book. Okay, select star from book. It's just here we said the name of the database, the name of the object, the name of the table. Okay, that's the only difference. Cool. just because we have to be more specific, because there could be like multiple databases around, there could be multiple tables with the same name across all of these different objects. So we have to just be a little bit more specific when we're working outside of dbfiddle. Okay, but I hope you guys agree that it's not too bad. Okay. But what I want to be able to do, so here I just ran a standard SQL query. You can see this is just SQL. But what I want to be able to do is I want to be able to run SQL queries from my console app. Okay, I want to be able to run an SQL query from my little console application here. Okay, so how do I do that? It's actually fairly simple. The first thing we have to do is open up a database connection. Okay, so we have to connect to a database. That makes sense, right? You can't query a database if you can't connect to it. So how do we connect to a database? We say string, connection string. Okay, so there's a thing called a connection string. This specifies, what the connection string does is it specifies the details with which you connect to the database. Okay, the details with which you will connect to the database. Okay, and as the name suggests, you can see the type is a string. Okay, it is literally a string. Okay, so I can jump over to like properties to show you this. Okay, so you can see it is literally a string. Here it is. I'll copy the string over, Control C, Control V. That is the connection string. So what is this specifying? You can see we've got a data source. Okay, all that.
It's going to be muted because I have to run out.
Ooh, I hear someone talking.
Yeah.
Hey, Tadiwa, welcome. What's up? Glad you could make it. You say you have to go soon. I don't know. So you can see here we've got a data source. So it's pointing to user PC. Okay, what is that? That's the name of my computer. Okay, you can imagine this being another URL, the name of some server on the internet, whatever. But this is just pointing to my computer. Why? Because the AdventureWorks database is on my computer. You can see it says catalog equals AdventureWorks. That's the name of the database. Integrated security equals true. Okay, so that's just saying we are connecting to this securely. Okay, nowadays all database connections will probably specify this, so we don't have to discuss it too much. It's almost like the default now. Okay, cool. Yeah, welcome. So cool. We specify this. You came at a kind of right time. We're learning how to connect to a database from a C# application. Okay. So we specify the connection string. That just specifies some of the details of the database, like where it can be found. That's the data source. And the name of the database. That's the catalog. Okay. And then we can open up an SQL connection. Okay. An SQL connection. Now, okay, I'm going to change from this slide because it'll give away the answer. Do you guys remember from back when we were learning databases, or not databases, when we were learning about websites, right? You guys learned that there were two sides to a connection, right? Basically, what we're doing here is we're making a request to a server, right? So what are the two sides of a connection? The two sides of a request. What are the two sides? We've got I actually just told you one of the sides. So I'm asking for the other side, okay? On the one side, we have the server. On the other side, we have the client, of course. So in order to connect to a database, we make our console-based application. So our little C# application here, what we do is we make it an SQL client, okay? An SQL client. And how we do that, system.data.sql client, sorry. So inside system.data.sql client, this is a namespace, SQL.sql clients. SQL clients is the name of a namespace. And in it, there are a bunch of classes specifying various things that allow you to make your console-based application an SQL client. One of the things is an SQL connection, okay? SQL connection. And all this is it's a class that it says right there, right? It says represents an open connection to an SQL server database, okay? That's that. So you see it says this class cannot be inherited. This class cannot be inherited. What does that mean, guys? What keyword did they use to create this class? Tariq, you mentioned that you wanted to study objects more. Do you remember this? This is good revision. Why can this class not be inherited? What keyword did Microsoft use to create it? You guys remember, what if I don't want a class to be inheritable? I only want you to be able to instantiate it, to create an object of it. Private, not quite. Not quite. There's a more general term for it when it's applied to a class. So you're right, you can make a property private. Protected means that the property will also be inheritable. But no, think of the level of classes. So we have like, let me ask you this. What's the opposite of abstract? So if you guys remember, abstract, as we saw it earlier in the lecture, actually, but you weren't here yet, Taddy. But abstract means that you can only inherit, right? So what's the opposite of that? Meaning you can't inherit, you can only create instances of the object. Does anyone remember? It might be a difficult one to remember. The word is sealed, okay? So that's why SQL connection cannot be inherited. That's just a little bit of theory though. Practically, it's very easy to use the SQL connection thing. You just create an object of type SQL connection. I'm gonna call mine connection. And we create this object exactly how we create all other objects. So it's SQL connection, that's the name of the object, equals new SQL connection, okay? Bam. And then you have to give it the connection string, okay? So that it knows what database you're connecting to. Okay? And that's that. Cool. So that's how we that's how we specify the connection to a database. Okay. So bam. Next, we can create a query. So obviously, it's useless just having a connection to a database. We want to actually be able to use it. So we create a query. These are called, there's another object provided by data.sql clients called the SQL command, okay? So we can say SQL command, and we can read the little blurb about it. If you forget, this is why it's nice using an IDE. So it says, represents a SQL statement or stored procedure to execute against an SQL Server database, okay? So executes against a SQL Server database. So notice it needs a server. So all SQL commands, so I'm going to call mine command, need to be linked to a connection, okay? So we've got our connection object right here, connection object. Oh, sorry about that. We want to just say connection string. There we go. So we've got our command, we've got our connection object. So I'm going to say connection dot create command, okay? Creates and returns an SQL command object associated with the connection. So we created our connection and now we're creating a command. And you guys will see the command is literally, so the stuff you put here is literally just SQL, okay? So I'm going to say select star from adventureworks.person.person. So I can copy that across, Control C, Control V, okay? We can add some, you guys all have, so this is, I think this database was made by Americans. You guys all have names that probably wouldn't show up in an American database. So I would search for like one of our first names. I know that there one name that does occur in it. We can say, sorry, let me just, sorry. Okay, we don't specify the command here yet. Okay, so that'll create the command. And then we specify the query, like the actual command inside the command text property like that, okay. Let me just backspace those two things. Okay, there we go. So that's where we specify our command. I'm going to add a where statement to select a particular first name just because that might be more interesting. So you can say like, let's test it out over here just to show you guys. It is literally just SQL. So we can say like where first name equals, what should we make it? Like Alexandra. That name should show up. Oh, I need to make one more change. Sorry. Like that, I think. Yeah. Can any of you guys guess why is it in single quotes? It wants this, in this case, it wants the string to be in single quotes. If you can imagine it here, actually, okay, I can just tell you this because it's pretty strange. So The reason it wants it in single quotes is because you can see that the command is in double quotes, right? So if here I said like where first name equals Alexandra, like that, first name equals Alexandra, you can see that it gets very confused. You see how confused C# is now? Because it's like, okay, so we have an open quotes, close quotes, Alexandra is just not in quotes, then another open quotes and a close quote. So you see, putting it in single quotes solves that problem. If we just put Alexandra in single quotes instead, like that. See, so now it's not confused. Okay, but yeah, anyway, so that's why you specify it in single quotes when working with SQL inside C#. And you can see that, syntax near, I'm a bit confused now as well. Oh, what's going on? Oh, someone drew, I think. That's what that is, yeah. But in Visual Studio instead, wait, is that what we're doing in DB Fiddle? No. So this is just in Visual Studio. Yeah, exactly. It's exactly like what we're doing in, I need to say person. Okay, specify the name of the table, I think. There we go. So now you see it fetched everyone whose name is Alexandra. So there's 93 people with the name Alexandra in the database. So I had to just specify that the table we were looking at was person. But yeah, exactly. So we're just working with a much larger database that has like 19,972 people in it. And we're contacting the database from, so you can see in total, there's 19,972 fields. Let me just expand it a little bit so you can see the number. There you go, 19,972 people, see. Cool, anyway, let's jump through this because we actually are running out of time to get, although, so you guys don't mind, right? I suppose I will record, so don't worry about it if you can't stay the full thing, but it will take some extra time because I do want to finish this week so that you guys can focus on exams, but we will be here for some extra time. Cool, so that defines the SQL command, and it's exactly like, yeah, Teddy, you're correct. So this is exactly what we're doing in DB Fiddle. It's literally SQL, but it's just, we're querying the database from a console-based application. So you can see we can specify our query as a string, and then it takes that query to the database in this SQL command object. The database that we're connecting to is defined by connection, and then it queries it and it'll give us the response. But how does it give us the response? So that's the next question. So that's this last bit. We can actually run the query. So we can say, okay, connection.open. You guys remember back in chapter 4, there is a difference between initializing and using, right? Like, or rendering. So here the SQL connection is initialized, right? So it's created, everything is set up, but the connection hasn't been opened yet. Here is where I open the connection, connection.open, okay? So that opens the database connection. Then we can say, okay, cool, take the command and go and run it on the, so take the command, which has already been linked to the connection, right? SQL command equals connection object dot create command. So it knows which connection the command is written for, and we can gonna go and execute the command, okay? So we're gonna say SQL data reader. So we wanna use a data reader, okay? SQL data reader equals, and we're gonna take the command and we're gonna execute it, okay? Execute it. There we go. So that's going to take this command and it's going to execute it. And so now, just like with the what was happening when we were using the XML reader previously, we can just use this reader. It's very similar. I'm just going to say while reader.read. So while there's something in the response left to read, we're just going to output the response. Okay, so I'm going to say console.writeLine. Okay. And this is where it gets, so let's say I want to print out the first name and the last name. So two things. I want to print out the first name over there and the last name over there. Okay. But we have to get the values we have to get the values from the response. Okay. So I'm going to show you the query. So guys, remember, so this is what it looks like in SQL, right? You can see the table right here. I'm going to tell you as a little hint that each row is stored basically as an array, okay? So if I ask you this, if each row was an array, which index would I have to access in order to get the first name and the last name? Which indices, which indexes would I have to access to get the first name and the last name if each row of this table was saved? Is it 3, 4? First name and last name. Shall we count through? So 0, 1, 2, 3, 4. That's the first name, right? 5, 6 is the last name. Close. So it's 4, 6. Okay, because we're not looking for middle name, right? We're looking for last name. So this is last name. So you see 4 is first name, middle name is 5, last name is 6. Okay, so 4, 6. Okay, so we can say reader.getValue 4 and reader.getValue 6. Okay, and hopefully that'll work. So I'm just going to go run this in the console and we can see, so we're expecting like a lot of responses, like 19,000 responses. So I'm going to say console app 1. Okay. So yeah, I'm not sure if this is 19,972 to, yeah, no, fair enough. So I'm not sure if this is 19,972 responses, but you can see that it is a lot. So it looks like it worked. Okay, so that went and fetched every single first name and last name of every single person in our database. Okay, looks pretty good. If we wanted to only fetch the first name and last name of people whose names are Alexandra, we could say where person.firstname equals Alexandra, okay? And we put it in single quotes so that C# doesn't get confused about where the string starts and stops, okay? So that's why we specify single quotes, okay? I'm gonna save that, I'll build it again, and now let's run it again and let's see if it updates the, cool. So now it only fetched the Alexandras. Okay, you see Alexandra, 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 and all of, so those are all the Alexandras in our database, okay, cool. So that's working pretty well. We can now run a query on the database. Okay, pretty good. Now, cool. So there are a couple of things that we must just like pay attention to here. So as I mentioned, the command text is exactly like the SQL queries that we were running inside DB Fiddle. You guys can see the command text is exactly like those SQL queries that we were running inside DB Fiddle. The next thing to understand is that there are a lot of ways that you can run commands. In particular, there are 3. Okay, there are 3 options, 3 ways we can run SQL queries. I'm going to explain them all to you. So the first one that we've already explored a little bit is this execute reader. Okay, execute reader. And what that gives back, so execute reader will give you the entire response back in the form of an SQL data reader. Okay, so it gives you the entire response back in the form of an SQL data reader. Okay, and that's the same as the XML reader, basically, where it's only forward only. Or if you weren't out of that part of the lecture, it's the same as a file reader. Okay, forward only, you go down through the file with reader.read, as you just saw here. So we just used this SQL data reader to go over the entire response. It gave us back the entire response. That's what execute reader does. Okay, but there are others. So there is also execute scalar. So this is fairly easy to understand. This just returns just the first cell. Okay, just the first cell. So let me actually just show you that. So it will return literally just the first cell. So if I say I no longer know that it's going to be an SQL data reader, it's just a variable. I don't know what type it's going to be. So I just say var reader, and I'm going to say command.execute scalar. Okay, command.execute scalar. So now we no longer have a reader, so we can't read over it, but we can just print out reader. So I'm just going to say console.writeLine reader or whatever. Hopefully it doesn't complain too much. Okay, cool. So now it's just giving the first cell back, just the first cell. And what do we mean by cell? We mean just this, just that first cell, not the first column, not the first row, just that cell. that first cell is what it will return. Okay, execute scalar. Now you might be wondering currently, like, wow, that seems very pointless. So like, why would you ever do this? So I'll run it now. You can see it just prints out, because the first Alexandra, so Alexandra Adams in the database will be row 10,263. So let's just scroll down to that. 10,263. Okay, that's going to be a lot of scrolling. 10,263. So in our case, for our query, the first thing was this, Alexandra Adams. You see, 10,263. Let me just make sure we're running the same query. So I'm going to say where person.firstname equals Alexandra. Okay. That's the query we just ran inside the console. And you can see the first cell is 10,263. Okay. The first cell. You see that? 10,263. That's the first cell. So that's all it returned. Now you might be wondering, okay, this looks very pointless. Why does this exist? So the reason this exists is because it's very fast. And in certain queries, it makes sense to only want the first cell. So I'm going to give you a simple example of a query like that. It's very good for counting. Okay. So if I quickly wanted to find out, so you see, I run it here. So that's running, this is getting so this is select star from person. So it's fetching the entire table, okay, all 19,972 people, okay. So when would I want the first cell? Let's say I was counting the number of people in this database. What you can do is you can say count, okay, count, and you can put the like asterisks inside brackets, okay. So I just want to count it. I'm no longer fetching all. I'm just counting it. So I say select count star from adventureworks.person. Now you see when I run this, so I'm going to execute it. Sorry, what did we do wrong here? You just think. Okay, cool. Sorry, I ran it weird. So you can see it just returned a single cell, right? 19,972. It just returned one cell. So in this case, execute scalar would be very useful because execute scalar is very fast because it can discard most of the response. Exactly. For counting, for averaging, it also works for averaging. There are a bunch of things where you only get one value in your response. And in those cases, this is very useful. That's when execute scalar is useful. So when it just returns the first response. So you can imagine I'm going to replace let's count the Alexandras. So I'm going to say select count star from adventureworks.person.person where person.firstname equals Alexandra. So that's our query. And we're executing scalar. So it's just going to give us the first cell into reader. And then I just print out reader. So let's build this quickly. I'm going to go run that inside command prompt. But yeah, exactly, Tari, to get the total. So this is going to give us you see it gives us 93, okay? So there are 93 people with the first name Alexandra in the database, okay? So that's what execute scalar is for when you're using queries like that. And the next query, the other one is execute non-query, okay? So this is returning the number of rows your query affects. So I'll give you a quick example of this. So super quick. If I change, so what I'm going to do, I'm going to run this statement. So I'm going to run updates, okay. You guys remember what update does? It will update particular columns. So I'm going to say set first name or set person.firstname rather. Person.firstname. Ooh, sorry. Let me think what's going on here. Set person. What am I doing wrong here? Update adventureworks.person set first name equals, oh, sorry, I think I was being silly. It was relating me to the foreign key. Set first name equals Alexandra, where person.firstname equals, okay, so let's flip those around. So all this is going to do is everyone who is currently saved as Alexandra in the database, their name is going to be updated to Ali. Okay, so that's all this is going to do. Okay. So I'm going to run this. Okay, and it ran. And all it said back was 93 rows affected. You see, this gave no response. It didn't give a result. Okay. Ooh, okay, Dape, cheers. Thank you for coming. Do catch up with the rest of the lecture when you have the time, eh? But yeah, sorry, we do have to take the extra time so that we can finish this week rather than using your time next week. Cool. So now there are no longer any people with the name Ali and with the first name Alexandra in the database. They've all been changed to Ali. And you see, it doesn't give me a result, right? It just gives me the number of rows affected. And that's what execute non-query is for. When you're executing a query that doesn't return a result, it will just return the number of rows your query affects. So if I run this exact same query again, you'll see that it now returns 0 rows affected, right? Because no rows were changed because there was no one with the name Alexandra. If I flip Alexandra and Ali around again, okay, like that, you can see now it'll say 93 rows affected, 93 rows affected. If I run it again, 0 rows affected, okay. So when do you reckon we'll be done, sir? Probably within probably by 5, hopefully, but we must speed. So cool. So that'll update the database. So I'm going to do that quickly. So I'm going to run this update command inside our C# here. So there we go. That's our update command. Instead of saying execute scalar, I'm going to say execute non-query. And this is going to return an integer. Okay. Going to return an integer like so. So you can see currently this is probably going to say 0 rows affected. So you can see if I just run this, it says 0 rows affected. Why did it say 0? Because it didn't change any names. But if I change the Alexandras back to Ali, so like that, just switch them around like so, then you can see that now, I need to recompile, obviously. So now when I run it, you can see it prints out 93. Okay, so execute non-query is when you're not running a query, you're running like an update or a delete or something like that, okay? When you're running an update or a delete or any of those kinds of things. Okay, then it will just return the number of rows that you affected. Okay. Cool. So that's how you connect to a database. Those are the 3 ways we can run SQL queries and statements on a database from a C# application. We can use a reader that returns the whole response. Scalar returns just the first cell. Non-query returns the number of rows affected. Okay, so that's that. On to the next bit. Okay, this we've kind of already covered, actually. We could save some of this for revision. So it's just about the system.io namespace. So we have covered this before. It's like a stream reader, but there's one like extra case here. So system.io provides, we've used it before to read from a text file. If you guys remember last chapter, we created that console-based application that read from a text file. How this works is it's something called a stream. Okay, we kind of just glossed over what a stream was the first time we covered it. So a stream is just a flow of data from one source to a destination, from a source to a destination. The source and the destination we call a backing store, and the place in memory where the stream is stored in the middle is called a stream. Okay, so for example, we could go from a database to a file with a stream, right? We could go from a file to the console with a stream. Okay, so that's what a stream is for. That's what a stream is called. Okay, so great. How do we do this? We use stream reader or stream writer, okay, to open up a stream wherever we want. So text files. This is to read and write from text files. We could use a stream reader and a stream writer, which you guys have seen before. Stream reader and stream writer inside system.io. The problem with text files is obviously a text file is not very good for storing videos or images or music, right? In order to store those things, we use a binary reader or binary writer, Okay, so that's just, it's the same as a stream reader and stream writer, except it writes everything as ones and zeros. Okay, so that's good for storing images and videos and sounds. Okay, now here I would have given you an example of, instead of writing to console, we would write the response of our SQL query into a text file. But to be honest, it's fairly easy to do. You can see the solution inside your textbook as well. You've already seen how to write to a text file and read from a text file. So hopefully you forgive me, I guess, and we can pass over this. Okay. So you can just use a stream writer to write to a text file. Okay. But yeah, it's basically the same as writing from a console. I guess we can do it super quickly, like stream. If I just say, it is like super quick. It's really not difficult at all. So we can say system.io. We can say stream writer. Oh, sorry. Let me just. Okay, now it's auto completing again. So stream writer. We can call it writer equals, do we create a new one? I think so. Okay, and we need to give it a text file to read. So I'm going to say person.txt, okay, like so. So I'm just going to create that file here. New text documents, person.txt, okay. And cool. The query we're going to run is select star from adventureworks.person.person. And all I'm going to do is instead of writing to console, I'm going to say writer.writeLine. Okay, like that. So I'm literally, all I changed was instead of saying console here, I'm now using the stream writer to write to person.txt. Okay, I'm going to build that. I'm going to run it inside console, and hopefully it just works. Okay, it's done. Let's go check out our persons.txt file. And you can see it wrote out the first name and last name of every single person to the text file. Okay, so that's an example of how to use a stream writer. You've seen a stream reader back in chapter 5. So that's that. Cool, on to the last thing. It should take us about 15 minutes. I'm very sorry for using your extra time, guys, but this is the last thing of the course. So use that to motivate you. Okay, now with the XML reader and SQL data reader, so with the XML reader and the SQL data reader, there was a specific keyword that I drew your attention to in the little blurb that it opens up, right? And it should appear here as well, actually. Let's see. Oh, no, if it was a stream reader. So I'll give you that little hint. So I'll mouse over stream reader. Does it give it here? It doesn't actually. Ooh, okay. It doesn't mention the term here, but it does apply. It does apply. Do you guys remember what the term was? I drew your attention to it. It was in the blurb. Okay. It was something like, this provides a FOST, non-cached, and what? FOST, non-cached, and what? And it was the XML reader and the data reader. And actually the stream reader, it's the same. It's the same. So does anyone remember what that term was? If we think about the word stream as well, it kind of makes sense. Can a stream go backwards? That's a little hint I'll give you, in order for one of you to remember this term. Can a stream go backwards? It can't, right? So what do we call that? What do we call that? What's a good way of describing that? Okay, I'll open the blurb because I do want one of you guys to tell me. I don't want to tell you. So I'm going to open up, I'll say SQL data reader. Could anyone see the word there? SQL data, oops, sorry. Anyone? Read the little blurb that it's popped up there. What is the keyword that I want you guys to remember? Okay, forward dash only. Okay, forward only. Exactly. Yeah. So that appeared in both the SQL data reader, the XML reader, and it applies to the stream reader as well. They are forward only. And guys, that's a huge disadvantage. If you're working with some complex data that you're fetching from a database, sometimes reading forward only is really ineffective, right? Because you can imagine a lot of cases where like you're reading through some data and you read the first bit, you read the second bit, you read the next bit. And once you read that next bit, your program realizes something. Maybe there's like an if statement, there's a condition, something, you see something that changes how you interpret the earlier data. But if it's forward only, there's no way to go back. Okay. Also, it doesn't, like those forward only, those simple readers don't provide any way to actually work with and manipulate the data inside your memory, okay, inside the computer's memory. It works like this, like these graphics you see over here. We go from the source, we've got a source, we go to the, we go into memory, okay, we process it, we go reader.read, okay, and it reads that first line. That line, we can do some stuff with that line, but then it goes to the destination, wherever the destination is, okay? And the destination can be anything. It can be the file, it can be console, it can be like an abyss, you can just delete it, right? It can be anything, okay? But we read from somewhere, like a database or a file or an XML document, we process it and we can go to a console, the file, a database, or an XML file, or wherever, okay? But the issue is we go line by line, right? It's like, SQL data reader that gets the response from the database. We say .read, we've got the first line of the response. We process it, we write it to wherever we want to go. We get the next line, reader.read, we process it, it goes to wherever we want to go, okay? And that's quite it's nice, it works for a lot of things, but not for everything, okay? Sometimes you want to be able to manipulate the data inside your database. You want to be able to do things, inside your memory, right? Inside the computer's memory, you want all the data available. You want to be able to work with it, okay? It's slow to read from flat files, from XML files. It's slow to connect to a server. You would rather store things in memory, and you would rather do it with relations, okay? You want relations in memory. And so C# provides a way for you to store things in memory like this, right? Like when we're talking about flat files, and by the way, by flat files, we just mean like a data store on your computer, like a text file or an XML file would both be flat files, or a binary file to store like music or whatever would just be a flat file, okay? That's all flat file means. So it's just slow to read from those, as you've seen. Well, it's slow to read from them continually, right? Like if you read the whole response and then you realize something and you want to process the data in a different way, now that you've seen some of it, you have to read the whole thing again, right? You would much rather just store everything in your memory so that you can work with it live, okay? So C# provides a thing called a data set that can do this, okay? So data sets can store all of this relational data from your database in memory, okay? So there's two ways we can populate it. The first one I'm not gonna spend time on, it's very simple. So you can say you can create a data set object, and you can read the data from an XML file using read XML. And you can also write the entire data set to an XML file automatically using write XML, okay? Fairly straightforward, you just must remember, like you can see from the name what it's intending to do, okay? What we really care about is this one on the right. This one is pretty complicated. It's called, you can use an SQL adapter to fill a data set, okay? And that's what we call it. We call it filling, okay? SQL data, SQL, yeah, cool. But I'll just show you it's in code, and then you'll understand, okay? Cool. So what we're gonna do, it'll be very similar to what we've got here. And for those of you who have your textbooks with you, this kind of thing will be on page, is it 171? Yeah, 171. Okay, fairly straightforward stuff though, so we'll just jump into it. So we've got a command right here, okay, command text, okay. In this case, I don't think we'll need an SQL command because we've got the adapter. Let me think about this. Yeah, we won't need, we just need the command text. Okay, so I'm going to say string command text. I'll just call it command, and we can remove the actual SQL command object because the SQL adapter is going to handle that for us. Cool. We open our connection. That's cool. And what we're going to do, we're going to hold. So previously we were using the SQL data reader, right? Which provided that forward-only access we were talking about. But instead of that, we can read into an SQL data adapter, okay? SQL data adapter. And if you read the little blurb, it says, represents a set of data commands and a database connection that are used to fill the system.data.data set, okay? That's its only purpose. All the adapter does is fill a data set, okay? So we're going to use the SQL data adapter in order to create a thing that we can use to fill a data set. I'm going to call it adapter. We're going to say new SQL data adapter. The constructor of SQL data adapter takes in two things. It needs the command that it is going to run, okay? The command that it is going to run, and the connection that it is running that command on, okay? So I'm giving it command. The command is select star from adventureworks.person.person. And the connection is this connection object we created here. Okay, cool. Hopefully that makes sense to you guys. So that's just what the adapter is doing. And the only purpose of the adapter is to fill a data set, okay? So what I'm gonna do, I'm gonna create a data set. I'm just gonna call mine DS, okay? Data sets, DS, actually, you know what? I'll call it DS person because it's gonna be holding the person table, okay? Equals new data set. That's that. So I've created a data set. What I'm going to do, I'm going to use the adapter to fill this data set. So I'm going to say adapter dot fill. Okay, adapter dot fill. So adds or refreshes rows in a specific. Okay, cool. The blurb isn't too nice there. But all this is going to do is it's going to take the response that the adapter got, right? Because we gave it the command that it must run. Okay, it's going to fill DS person. Okay. With, and I can give it the name of the table that I want it filled with, okay? The name of the table that I am using is called person, right? Person, okay? So that's the name of the table, okay? Adapter.fill, DS person, person, okay? So this is gonna take the person table that we fetched in this query, and it's going to fill the DS person data set with it, okay? And what this allows us to do is it stores the entire table. Okay, so that was the difficult bit really, explaining this fill thing. So you give it the data set that you want to fill and the table you want to fill it with. Okay. And once you've got that, once the adapter has been used to fill the data set, it's a super cool, easy thing to work with. Okay. So the whole table. So if I go, we can, okay, guys. So you can imagine I've filled it with one table now. There could be multiple tables. No problem, Taddy. I'll upload the recording. Sorry I took up your guys' extra time. But I think it'll be worth it so that you guys can have some free time in November to study and stuff. But yeah, cheers. So cool. I'll just finish up. So we've got this. Can you guys answer this for me? Who's still here? Not many people. The people who were here at the beginning. Glad you guys could stay. So how do we, what repetition structure would I use to iterate over a collection? What repetition structure would I use to iterate over a collection? Do you guys remember? What is the ideal repetition structure for iterating over a collection? Remember, we learned 4 repetition structures way back when. Which one is ideal for the task of iterating over a repetition structure? I mean, iterating over a collection, like an array. When you don't know really how many things are in the array. Anyone have any ideas? Oh, nice. Sorry, I was looking at the participants tab instead of the chat. Okay, cool. Yeah, nice, Tariq. Exactly. We would use a for each loop. So we're going to say for each. Okay. So what the data set does is it stores the whole table inside memory. Okay. So we can access it in an object called a data table. So I can say for each data table in data set person, DS person, okay, inside my data set. Okay. And I have to say, okay, I need the collection of tables. So I'm going to say dot tables. And you can see it says gets the collection of tables contained in the data set. So there we go. We say data table in ds person dot tables. Okay. Now each table, in this case, we only have the one table person, but you can imagine having more. And so now each table has rows, right? So I can say for each data row in table dot rows. Okay, so for each, this is essentially saying for each of the rows in the table, right? For each of the rows inside the table. Okay, and you can see rows just returns the collection of rows that belong to this table. So you can imagine this is just like an array, right? It's just an array of rows. Okay, and now I can use that row exactly how, like pretty much exactly what you would expect. So it's like this. So I'll show you it now. I can access this row in position and like the name of the column. So like first name is the name of one of the columns. I could also access its row. I could also access row in position last name. Okay, that's also one of the columns. Okay, row in position first name, row in position last name. Okay. And all that's going to do is, as you can probably expect, it's going to, in place of 0, it's going to put row first name. So it's going to put the first name of the person and the last name of the person. So this is going to go ahead and fetch the first and last name of every single person in the database. So I'm going to go build solution, jump over to command prompts. I'll run console app 1. And you can see, so it takes some time to populate the data set, but then it gets the first name and last name of every single person in the database. Okay. Exactly like what we did in the first place, except now it's being read from memory. Okay, it's being read from memory. And you can see I can access first name and last name directly. I no longer have to do that fancy thing with arrays, okay, where we go like 4 and 6. Okay, so that's it, guys. That's the whole course. Congratulations on finishing. Glad you guys stuck with it until the very end. But obviously I will upload the recording for all of the people who couldn't stay the whole time. But yeah, congratulations. Been nice teaching you guys, and I'll see you in like our revision sessions. Good luck with exams and the rest of school and whatever, and I'll keep in touch. But yeah, thank you for coming. In uni, do we learn all these things, but in depth? You definitely will not be learning about, it's more like you learn all of these things with less depth. If by depth you mean practical, then you won't do much practical stuff. I mean, you will occasionally use like Python or whatever to develop an algorithm, but it's more theoretical than this course, uni, definitely, much more theoretical. Like, yeah, so you would cover like this stream thing. You would cover this in more theoretical detail, but you would never actually use like a C# stream reader. You'll cover this in more theoretical detail, like what is the source? Why is it a backing store? Like how exactly is the stream processed in the computer's memory? Learn some maths about it, that kind of stuff. I don't know if that was the response you were hoping for, Tariq. No, but it is interesting, and you do some practical stuff like Python, basically Python and some C. And there are some very practical courses, especially once you get to like 3rd year and stuff. But in 1st year, it is mostly theoretical and like maths and stuff. But it's cool. You get like a good depth of knowledge. But yeah, it depends what you mean by depth, I suppose, is the answer. But anyway, cool. But yeah, I guess the general thing with uni is they basically say that you'll learn everything on the job. Like if you want to learn C# specifically, you would learn it when you get a job using C#. Like if you have a good theoretical understanding, you don't have to be taught the specifics of any language. You can just pick it up as you go. But yeah, anyway, I hope that answers your question, Tariq. Cheers, guys. If you have any more questions, you can ask like on Discord or WhatsApp and I'll answer. And there should be one more of those database modules things, which I'll also post, explaining this last little section that we kind of rushed through. Yeah. Bye-bye. See you guys whenever. Cheers, Tariq. Cheers, Kreflo. Thanks for coming.